Hi, year 13. I just wanted to go through with you about chemoreceptors to finish off this section for our next lessons on Thursday. Okay, so if we can all turn to page 78 in our books, and I want to go through with you about this whole process again. Okay, so the idea, I'm going to read it a little bit to you and then talk to you about what was going on. So controlled by chemoreceptors. So the chemoreceptors are found in the wall of the carotid arteries, the arteries that serve the brain. They go up from the heart up towards the brain. They are sensitive to change of pH, which we talked about, of the blood. That can result in changes in carbon dioxide concentration. So if we think about that for a second and then look over to the left-hand side of the page where it says increased muscular metabolic activity, that means doing more stuff, running around. Okay, your muscles are contracting more. If that is happening, more respiration is taking place. From what you've learned with Mr. Ruffey, more respiration taking place. We're thinking increased concentration of carbon dioxide from respiration. So that takes down more carbon dioxide produced by tissues from increased respiration. Therefore, the blood pH is lowered. So when the blood pH is lowered, chemical receptors from the carotid arteries increase. The frequency of impulses sent from that receptors, from those chemoreceptors, up to the medulla oblongata. So if the medulla oblongata, that's the part at the bottom of the brain that's receiving the information from the carotid artery. Remember, this is we're thinking about is the sympathetic nervous system. Okay, so the center of the medulla oblongata, that speeds the heart rate, increases frequency of impulses that are sent from it to the SA node. The SA node is that part at the top right-hand side of the heart that we were looking at in the previous pictures and diagrams before. Okay, so the SA node now is going to be sending more impulses, so the heart rate is going to increase. So the SA node increases heart rate because it's been told to increase its rate of transmission. Increased blood flow, therefore, because the heart is contracting more often, doing the same thing as it would do each one, therefore more blood is going to be moved around. If the more blood is moved around, then we should say that therefore there is increased blood flow. The carbon dioxide is going to be exchanged in the lungs more often. So which we haven't talked about here, but at the same time there will be an increase in inspiration and expiration, so that our breathing rate will also increase along with our heart rate increasing. Therefore, exchange of gases will increase, will replace the oxygen that we needed from the oxygen debt, and also the carbon dioxide will be removed. Okay, so that talks about the chemoreceptors. So when the blood has a lower amount of carbon dioxide, therefore the pH then increases, and then this increase in sending the rate to the medulla oblongata of nerve impulses, that then stops. So then that stops sending the extra impulses to the SA node, and the SA node will return back to doing what it normally does. Okay. Now, when it goes back to, so when the increase happens, so the increased blood flow, the carbon dioxide will be removed. So what will happen there? The pH will go back to normal. So the chemoreceptors in the carotid arteries aren't sending extra signals, so they're reduced number of signals. The medulla oblongata reduces its frequency, and then so we get a reduced heart rate, and that's what happens when it's back to normal. But that only happens when the carbon dioxide levels drop, and when therefore the pH goes back up. So that's why we continue after we're running. So we've run a lot, and if we increase the carbon dioxide in our blood from extensive running, therefore we don't return back to normal straight away until the carbon dioxide has been removed from our blood. Okay. So I hope that helps talk through how the chemoreceptors work in the heart. Okay.